Okay, so our project today is going to be a solar-powered remote water filtration device. We're Team Dynamite. So the problem description. What we're looking at is two different challenges from the National Academy of Engineering. Problems 2 and 9 out of 14. 2 is to make solar energy economic, and number 9 is to provide access to clean water worldwide. Another thing we wanted to focus on is remote areas that need continuous access to clean waters that don't have them yet, such as areas in Africa and the mountains. And then our biggest limitations are going to be portability and that the energy used in the system is self-sustaining.
Okay, so our system's objectives and design constraints involve being able to filter contaminants out of the water. These include particles and pathogens. We wanted our system to be able to utilize solar power as an energy source. We wanted it to be portable and we wanted it to be easy to use. So for target constraints, we targeted a flow rate of at least 1.2 liters per minute, a target maximum weight of 25 pounds. We had a budget limited to $230. We wanted the design to be self-sustaining, meaning it could operate detached from the electrical grid. We wanted it to be less than 8 cubic feet, and we wanted it to operate off of a 10-volt power supply.
It's going to be a brief overview of how our system works and operates.
This is our solar-powered water filtration system. In our system, there is a solar panel, our intake tube that has a large particle filter, and here's our output device that has a micron filter to filter pathogens. On the inside, we can see all of our working components. So we have a pump, a battery, and a solar panel controller, as well as a pump or a gauge that measures when our filter is going bad. A pressure gauge. Use. Here is a device. Basically, the filter pops off if there's too much pressure in the tube or if the tube is kinked. This button here acts as an on-off switch for our system. As you can see, our system is filtering water, and we don't have any kinks in our hose, so our water filter is not popping off.
So compared to what we actually built versus what we theoretically wanted, we achieved a actual flow rate of nearly 4 liters per minute, which is well above the constrained flow rate of 1.2. We're well below the target weight at 25 pounds. We achieved 9 pounds with even with the wooden housing. We're slightly below the cost of $230 with $215. We set a target volume at 8 cubic feet so that it fits within a trunk, like a car trunk, but our actual design was well below that at 6.6 cubic feet. And power supply was well within the target constraint of 10 volts, which is 13.4 volts. And our design is self-sustaining.
Improvements to our design that would be made if we had more time or more resources would be getting a smaller solar panel so it better fits the frame. Getting a food safe pump to be absolutely sure that nothing is getting into the water, even though this pump is before the filter. Making the frame lighter to decrease the weight even more. Getting a virus filter or post-process for viruses to get rid of all contaminants whatsoever, and a lower range pressure gauge.
Thank you.
Thank you.